Hello my dear students. So in the last lecture we started the design problem. Okay, step number 1 has been completed. So what we'll do, we'll move for the step number 2. Okay, so these all things has been already explained in the last lecture. If you are not seen, please you can go through and you can come for the step number 2. So in step number 2 what we'll do, we'll calculate the maximum bending moment for this one. Okay, so what is the load that is coming, so all the things we'll calculate this one. Okay, so in this step number 2, so that is bending moment due to moving load plus bending moment due to self weight of the gantry. This is the thing we are supposed to calculate. So one more thing you have to remember. So the wheel loads you have to place in such a way that the CG of that span and the CG of that wheel should match. Okay, so this is the thing you should remember. So it is written also. The statement is written. The wheels are placed that in such a way that the CG of the wheel loads and one of the wheel are placed at equidistance from CG of the gantry girder. CG of the gantry girder. Okay, so we'll calculate the bending moment due to dead load. So first we'll calculate the bending moment due to dead load. So I will assume the self weight of the gantry girder is equal to 2 kN per meter. So still now we are not designed the gantry girder. So initially I will take the self weight of the gantry girder is also we are supposed to consider now while designing. So I will consider this one 2 kN per meter is the self weight of the gantry girder and self weight of the trolley, that is 0.3 kN per meter. So this is you can consider. So for that one total load is how much? 0.3 plus 2. So how much? That is 2.3 kN per meter. So factor load how much? If you have to multiply this one 1.5 into 3, 2.3. So that is 3.45. So this is the load, that is the maximum load that is coming on that one. So when bending moment due to dead load is how much? So if it is UDL means of what is the formula? If it is UDL, so that will be WL square by 8. So WL square by 8. So 3.45 is the load that is coming. L is how much? That is span of the gantry. So span of the gantry how much? That is 6.5 meter. No, 6.5 meter. W into L is 6.5 square divided by 8. So how much you are getting? 18.22 kilonewton per meter. So this is the due to this the movement is coming due to dead load. The moment is coming due to dead load. Okay, so here what we calculated, so maximum wheel load is how much? That is 267.18. Why? Because total load is 537.4.37 divided by 2. Why? Because it having two wheels, that's why 50% of load is transferred to each wheel load. So that's why it is diagram has been drawn here. Okay, so please, this is not a scale, please make go for this one. So this is the wheel, this is on one wheel that is going how much? 260 per net, and this is the second wheel. And I am putting this one exactly at the center. Means I am considering I have to place this one of the wheel. It should match the centroid of this gantry girders. Okay. So that is at a quarter span. I will take it will act at a such at a 1/4. The position of one wheel load from the center of span is the wheel base by 3. You can take that at 3/4. Wheelbase by 4. So wheelbase is how much it is given in the question? The 3.5 divided by 4. So that is 0.875. So means one of the wheel should be at a distance of 0.875. Now it is matching. Okay. So that is my center of the gantry girder and both the and CG of the wheel. It is matching. Okay. So this is the diagram what you are seeing. Again here we are going to calculate the things. Okay. So next what I will do, I will take bending moment at C. What I will do, I will take bending moment at C. So already you are aware. So bending moment with what? That is bending moment means force into perpendicular distance. Okay. So I will start with this one. So RD into what is the distance? So RD into 6.5. How it is rotating? Anti-clockwise. That is positive. Next 267.18 into this distance. 267.18 into 4.125. 4.125 how it is coming? So you can calculate this one. This is 0.625 plus 3.5. If you add this one, you are getting how much? 4.125. Means only the thing you have to understand force into perpendicular distance. What I am doing. So this is the force. So that is this is the force and perpendicular distance. Okay, so next, this is our next is, again I will take this one, this 267.18 into 0.625. So here I am considering only live load. So what I am doing, only live load, I am not considering this 3.45. So 3.45 is what? So it is the self weight of the rail. So here I am written only live load I consider. That's why I go for this one. Next I will go with summation of Fi. Summation of Fi means what? We are supposed to consider only vertical loads. Okay. Fi means this is 267.8, 267.18. Okay. So it is going downward, and RC and RD is going upward. Okay. So if you solve this one, you are getting the value of RC is 339.13. Okay, so for this one, RC has been calculated, maximum bending moment due to live load at F. So if you see in this diagram, so what is the maximum bending moment? So if you see this one, same here also. So we can calculate so while solving the problem, you have to make sure that you should do see by seeing the diagram also you can judge where the maximum bending moment is going to come. So if you see this diagram, so maximum bending moment is going to come at E, or it may come at F, or it may come at D, it may come at C. So you can so say at C and D the bending moment will be equal to 0. So it may come at maximum maybe at E at F. So if you see this one, RD value is maximum and distance is more. So definitely maximum bending moment is going to come at F. So that's why we are going to design for that value only. So you can calculate E also. We'll calculate E as well as F, and which one is the maximum that one is going to consider. So we'll take maximum and limit at F. So RD into distance, the 2.375. RD into 3.75. RD is how much? 195.23. Okay, into 2.375. That's 463.67. So I will take bending moment at E also. So bending moment at E, how will calculate? This RC into 0.625. So if we multiply this one, how much you are getting? 201.95. So which one is the maximum? So that is this one. So that's why I got one for 463.67. So this value has been considered. Okay. So next lecture we'll go with the next part. Okay. So in that one, what we are supposed to do means we take the maximum value, that 463.67. So after that one, so